Okay, if we are dealing with a fluid through a completely filled pipe, and let's imagine it's horizontal and there is no gravity factor, then there is no capillarity is of no particular importance, because capillarity actually happen if it's vertical. Now there are some forces which are inertial forces, the push of the water. There is force, frictional force, due to the viscosity of the fluid. If it's a oil, less viscosity. If it's a honey, more viscosity. Now the same thing is true for an aeroplane in the air. Now, if an airplane is flying at a high altitude or at low altitude, there is a reason that they chose a specific altitude, because at that the air is thin, less friction, and so on. They cannot go further up. The reason behind is then they will have a short of oxygen. They will consume more fuel, and they will reach like they will run or fly fuel rich, which means all their fuel is not burned properly because of less oxygen. So they choose a certain height. Okay. Now, if we are looking at submarine, which is submerged far enough, uh, when I say submerged far enough at a certain level, and it's not producing any wave, and it's actually moving. When submarine is moving, it's cutting the fluid, it's cutting the water. Now, when it's cutting the water on the surface of the submarine, that's where they cause the friction. Um, and that's the front of the submarine. There will be a lot friction as compared to the other side at the back. And obviously at the back, where it actually spins, it causes the turbulent flow. If there is more turbulent flow, you are losing energy. If there is laminar flow, it's less energy loss. It's exactly similar the principle of the wake behind the ship, or so on. Now, how does that relates to Reynolds number? Now, Reynolds number, we consider the ratio of the forces, inertial forces, and we actually make up a number. We actually experimentally design a number. It was named after a guy, Reynolds. He did a series of experiments to find the transition from laminar to turbulent, and so on, and back from turbulent to laminar. And he said that Reynolds number is a dimensionless quantity. It doesn't have any dimension. The formula for Reynolds number is this is the formula. Re is a Reynolds. Yep. This is the formula where V, or we call that nu, is the velocity of the fluid. This is the density. Rho is the density of the fluid. This thing d is the diameter of the pipe, and that bit here is the absolute viscosity of the fluid. Yeah. Okay. How does it relate to laminar and turbulent? If you are given all these values, you put the values in, press enter. If you are getting an answer less than 2000, the flow is laminar. If the Reynolds number is greater than 4000, it is turbulent. Now we only discuss laminar and turbulent, and the Reynolds number value can also be in between 2000 and 400. So if the value is between 2000 and 400, we call that a critical zone. So it is between the laminar and it's between the turbulent. It's not 100% laminar flow, it is not 100% turbulent flow. Sometimes it's very difficult to find or to calculate or to tell without doing a prototype that if the flow is laminar or turbulent, if the value is between 2000 and 400. Yeah, so it's extremely difficult. So this is why we have the CFD modeling. We do CFD modeling, we test all the cars and the aeroplanes and so on in an air tunnel to find out the flow is laminar or turbulent. Okay, if there is a turbulent flow and we want to make it a laminar flow, what we can do, the first thing is we can change the diameter. We can change the diameter of, we can change the viscosity of the fluid, but obviously if we are having the same fluid we won't be able to. We can change the type of the pipe. If we change the type of the pipe will have a less friction coefficient. So we will have a less friction coefficient, and that will help us to change the value of the Reynolds number. Okay. Sometime, because we said viscosity is directly linked to temperature, sometime we can increase the temperature of the fluid before pumping it from A to B. Hence, it will reduce the turbulency. But while you're doing it, you are utilizing excess energy. Now, there are two things. One is called the dynamic viscosity, and other is known as kinematic viscosity. The kinematic viscosity and dynamic viscosity, they have different formulas. Now, here, let's say we want to find out the Reynolds number. The kinematic viscosity of an hydraulic fluid is given 0.0001 meters square per second. So these are the units. If it is flowing, it should be meter per second. Meter square. Oh no, sorry, that's viscosity. Yeah, sorry. 30 millimeter diameter. That's the of the pipe. The velocity is 6 meters per second. We want to find out the Reynolds number. So if you just write this one down, please. So here we got the Reynolds number. This is V is the velocity, diameter, density divided by the mu. Now here we have dynamic viscosity. We don't have kinematic viscosity. So what here they got kinematic viscosity. Kinematic viscosity is, to get the kinematic viscosity, I can bring the rho down. When I bring the rho down, I need to divide it with the rho, and that is, this value is kinematic viscosity, which is given 0.0001. That viscosity is given. Yeah? And the velocity is 6, and the diameter is 30 millimeters. We need to convert that into meters. We put that in calculator, we will get a Reynolds number. Because this Reynolds number is a lot lower than 2000, which is 1800, so it means this one is going to be laminar flow. If it's around 2001, 2003, more than 2000, we don't know. It's closer to laminar, but it might be a little bit turbulency there. If it is 3900, it's a little bit laminar, a lot turbulent, but we still don't know it's 100% turbulent or not. More than 4000 is 100% turbulent. Less than 2000 is 100% laminar. Between these two values, it's a bit confusion. It's a laminar or turbulent. Okay, now we got a Darcy equation. If there's a fluid and there's a pipe long enough, if we measure the pressure at the start and we measure the pressure at the end, there will be difference in pressure. Pressure at the end will decrease, will be lower as compared to pressure at the start. And if you are measuring the pressure at a different point in the direction of the fluid flow, the more further you move from the starting point, the pressure will reduce. Now there's a reason, and you should know that for your exam as a bullet point. The reason the decrease in pressure is mainly due to the friction, and that friction will cause energy losses. If there's a question in a long pipe, horizontal pipe, what result in the decrease in pressure is horizontal pipe, the answer is the friction. And why friction? because it causes energy losses. If it's a horizontal pipe, a different story. The reduction is due to the gravity, due to the head losses, because something is pulling, the gravity is pulling it down. Okay. Now, friction.
So we'd always presume it's completely flat.
They will mention that to you. They will say like it's flat, it's horizontal, or it's a 30-degree, 20-degree at angle. Rather 20-degree angle, they will give you the whole length. They will give you the whole length, how far is from here and how high it is from here. And based on that one, you can calculate the length using a Pythagoras theorem. Yeah, trick. Okay. Now, finding the friction is not as easy as it look like. The friction coefficient plays a part, the diameter of the pipe plays a part, the force plays a part as well. So let's have a look at the equation. Now we got the equation for the head losses in a very long pipe, in which the velocity distribution has become fully established, which means we know the velocity at each and every point. Okay. Now we got the Darcy equation is given by this equation. So if you write this equation down, where L is the length of the pipe, D is the diameter, inside diameter of the pipe, V is the velocity, and G is the 9.8. And here HL is the head losses. So if you write down this equation, please. Okay. Now these are F thing, which is Darcy friction factors. That's actually a constant which will be given to you. So out of these 1, 2, 3, 4, 5 variables, G is going to be constant 9.8. Usually one is missing, everything else is given, and you can put that in formula and calculate the missing bit. So let's do one numerical question. Now, let's say we got a Darcy equations and we want to find the friction coefficient as in the previous equation. So we got this friction factor, Darcy friction factor. How we find Darcy friction factor? Darcy friction factor is equal to 64 over the Reynolds number. So rather having an F there, I can put that one as 64 over Reynolds number. Let's have a look at this kinematic sample question. Let's say we got a kinematic viscosity of any fluid is 0.001 meter square per second. It's flowing in a diameter, a pipe of diameter 20 millimeter, and it's a commercial steel pipe. Find the friction factor F in each case when the velocity is 2, when the velocity is 10. So you don't have to write it down. I will upload that one. To do that one, first when the velocity is 2 meters, we use that formula. We got Vd over mu friction of viscosity over the density, and we got the kinematic viscosity. We got the value, the velocity is 2, the diameter is that one, 0.02 meters, and that's give us the value of the Reynolds number. When we got the Reynolds number, we need to find out the friction factor. Friction factor is 64 over the Reynolds number. So friction factor in this case is 64 over the Reynolds number 400, 0.16. If you have a look at the Reynolds number here, it's a lot lower than 2000. So in this case, this is going to be 100% laminar flow. Let's say if you want to increase the velocity, now the velocity is 10 meters per second. Now we use exactly the same formula. Velocity is now 10, diameter is still the same, 0.02, and this was not given. This is given, but obviously we don't have the value for this and density. So we can divide this thing, bring the density down, get the kinematic viscosity, put the value, and you got 2000. 2000 spot on 2000. So it means it is still a laminar flow. More than 2000 is a turbulent. Yeah, but that is less laminar than the other one. You can say that. If I want to find out the friction coefficient, 64 over 2000, which is going to be 0.032. So friction coefficient has reduced. Friction coefficient is just a value. It does not